In this lesson, we're going to cover the face tool utilized in a sheet metal environment. We're going to start off by creating a new sheet metal part. From the English tab, I'm going to go ahead and select on sheetmetalinch.ipt. And we're going to start off, like most designs do, with a rectangle. And then we'll go ahead and we'll place a couple dimensions on there. So in this case, let's make it 5 by 3. And I'm going to switch to an asymmetric view. And now I'm going to return. And you'll notice in a sheet metal environment, I'm returned immediately to the sheet metal features and not returned to the part features. So even though we can go back and do our extrudes and revolves, what we want to do in the sheet metal environment is really utilize sheet metal tools. So I'm going to switch back to the sheet metal features panel. And you see I really only have a couple options at this point. I can't go back and remove or add material to something that doesn't exist. So we're going to start off by creating a face. And you can see that the rectangle is automatically selected since it's our only closed profile. I can offset its direction either to be positive or negative. And really, since this is the very first feature, there are really no options under the unfold or bend that are going to affect this flat. So let's go ahead and just click OK. Now let's experiment around a little bit what we can do with the phase tool beyond the first feature. I'm going to make the front plane the active sketch. And let's use the look at tool and we'll look straight onto that plane. So what I'm going to start off with is I'm just going to draw in a rectangle. Again, we can place some dimensions on this if we wanted to. So I can say that it's going to be 2 inches high by 3 inches long. And then of course we can come back off of this edge and say how long do we want it off of there. In this case, let's place it at 1 inch. I'm just going to spin my view around. I'm going to click on the return tool. Let's exit out of our sketch environment. And again, I'm going to use the face tool. So what I want to do is I want to turn this into a sheet metal part that has bends. So the profile is going to be our rectangle. And if I spin the screen around here a little bit, you can see that if I go back and modify the offset, it's determining which direction it's going to go. So now at this point, I can't go back under the unfold options. If I want to go back and designate how that's going to unfold under the bend, I said how is the shape for the internal side going to actually look. So let's start off with a straight. And on the right hand side, this is where we can determine the size of that. So I got to go ahead and click OK. Now if I spin it around, you'll see that the outside face here is coplanar with this face, because that's the way that we set it up to be. But we can go back and modify that. So in the sheet metal environment, it's no different than working in just regular standard parts. So at this point I could go back and just click on offset. You can see it has a dramatic change to our part. It's all depending upon how the sheet metal part is going to be used. Are you trying to hold the inside or the outside faces? Let's do one more example. I'm going to make this front face here the active sketch. And again I'm going to use the look at tool. And what I'm going to start off by doing is just drawing in a couple line segments. I'm going to create a disjointed body. Of course, at this point, we could go back and add some dimensions if you wanted to. For this example, I'm just going to leave it as it is. So let's rotate our screen around a little bit. And again, I'm going to click on the return tool. We'll exit out of the sketch environment. Click on face. Select our trapezoid. Now at this point, I can go back and click OK. And I have a disjointed body. Inventor does have tools to go back and join those together. It's called the bend tool. But in this case, I'm going to undo that and show you another method. Again, with the face tool, I'm going to select our trapezoid. But I have the option here to select an edge. And the edge that I'm going to select is going to be the edge that it's going to be joined to. So you can see that I have the preview showing what it's going to look like. So if I go ahead and click OK, you'll see that the feature has been created and Inventor has automatically taken those edges straight right down to the part. So let's go back and edit that one more time. We do have a second option that's available, is the extend bend align to the side faces. So if I go ahead and click that, click OK, you'll see what Inventor did is it kept my angle lines going all the way down, but it's transitioning to where it was, back from the straight portion of the line segments that we drew. So let's look at one more option with the face tool. I'm going to rotate my screen so I can look at the right side face. Again, I'm going to make that the active sketch. Let's use the look at tool again. Let's say I really do want to have an angled edge on this, but I want it to be joining at that angle. So if you want to do that, what I would suggest doing is actually drawing it in on the angle that you want. So in this case, I just drew in 3 line segments because I'm going to utilize the existing edge down here to close that off. Of course, we could go back and place some dimensions for project edges to get your geometry locked in. So let's click on return. Click on the face tool. Select our face. Again, determine if it's going to go to the inside or to the outside. For this example, we'll take the outside. Go ahead and click OK. And you'll see that the face feature has been created. Let's take a quick look here at the bend options. So if I go back to the face and under the bend tab, let's change the relief shape to round. Go ahead and click OK. And you'll see that our relief down here is now at a round. If I edit this one last time, under the bend is the minimum remnant. So if our geometry came very close to the outside edge here, and there was just a little bit of material, that's what the minimum remnant is going to tell us. So if it is within that small range, Inventor's just going to cut it off. So let's go ahead and click OK. Since we're not very close to the edge, we're having that relief shape closed in. In this lesson, we're going to cover the hem tool. The hem usually is placed on the sheet metal part and adds strength or rigidity. The file that we're going to use for this exercise is called SM Styles.ipt, and it can be found in your Chapter 10 exercise folder. I'm going to go ahead and I'm going to click on the hem tool from the sheet metal features panel. Then in the hem dialog box, first of all, what I'm going to do is I'm going to select an edge, place the hem on, and let's zoom out a little bit closer so we can see it. From the type list, we have a single, which is the default. I can place a teardrop, or place a roll. And for all of these, you can go back and you can designate the angle. So if I typed in 270, you can see that I'm now at 270 degrees. And finally, we have a double. Let me spin the screen around a little bit so we can see it at a little different angle here. So for each one of these, you can go back and designate the size and the length of each one of those. So for starters, I'm going to go back and change this back to a single, and let's change the length to 10 millimeters. So let's go ahead and click on OK. And we just created our hem. Spinning that back and around, you can see that it goes the entire length of the part. So you'll notice in the browser, the hem feature appears. So go back and make some modifications. I'm just going to double click on it. And the hem dialog box will reappear. If I change my mind and I no longer want that hem to go the entire length of that edge, I can expand the dialog box. And under the width extent option, these are the same options that we had for placing in our front edge. So in this case, the edge, that is going to go the entire length of the edge. We can determine a width, or we can do an offset. In this case, let's go ahead and do that. So I can go back and select points, and then I can go back and determine the length off of each edge. So in this case, we have 50 millimeters off the front edge, and the second edge, let's go back and change that to 25. And now these points that I selected, they are parametrically linked to the part, so if this feature does change, I'll always be maintaining that 15 and 25. The last one that we have is the from to option. For the from to option, you can select vertices, work points, work planes, or planar faces to determine the length of the hem. In this lesson, we're going to cover the fold tool that's available in the sheet metal features environment. The file that we're going to use for this lesson is called fold.ipt, and it can be found in your Chapter 10 exercise folder. A fold is going to allow us to sketch in a line, and about that line we're going to fold the geometry. So I'm going to start off by doing that. I'm going to make this front plane the active sketch. I'm going to draw in a line segment that's going to be starting at that end point. And I'm just going to draw it so it's going to be coincident to the edge and parallel. So the coincident portion is extremely important. This line that I'm drawing, it needs to extend to each of the extents forward. So let's go ahead and go explain a little bit more as we go. So I'm going to return out of the sketch environment. And then from the sheet metal features section, I'm going to go back and select on fold. I'm going to select on the line that I'm going to fold the geometry about. Let me spin the geometry around here a little bit. Now from the controls, you can go back and designate which side is going to fold, the left or the right side, and up or down. So in this case, I'm going to take all the defaults. I can designate an angle. Right now I'm going to keep it at 90 degrees. For the fold location, so when we sketched in that line, is that line representing the center of the bend, the start of the bend, or the end of the bend? So let's just work our way from left to right. I'm just going to go ahead and click on OK. And if I spin the model around, you can see indeed what happened with the sketch line is right in the middle. So let's go ahead and edit that. I'm just going to double click on the fold feature. Then let's change the location to start of bend. You can see that the preview in red is showing exactly what's going to happen. It's shown here. And let's do that one more time. Let's change it to end of bend. So you can see exactly what's happening. You definitely get different results. When you sketch in that line, you're going to determine how are you going to utilize that line. I'm going to make one more fold. I'm going to make this front plane the active sketch. I'm going to use the look at tool. I'm going to draw in an angle line. The lines don't have to be horizontal or parallel, but in this case you see that the line definitely is falling short of the entire face that I want to fold. So let's just see what happens. I'm going to click on return. Click on the fold tool. Notice that the bend line arrow is red, meaning I need to select out of it. As I try to select on that line, nothing is happening. So what I'm going to do is I'm going to get back to that sketch environment. Just make it active. And I'm just going to drag the endpoints back out so that they're going to be touching. And at this point I'm going to go back and place in some dimensions if needed. So let's change that to 20 degrees. And for a start point, let's place that in at 10. Now I'm going to click return. Back off a little bit. And again, let's go back and do the fold tool. You'll notice now I can select that line. And we're right back where we were before. So in this case, I'm going to say that that is the center. And let's fold this at 45 degrees. Okay. And we just bent our part at that 45 degrees based on the angled line of 40 degrees. In this lesson, we're going to cover the bend tool. The bend tool allows us to go back and place in bends between two disjointed bodies or faces. The file that we're going to use for this lesson is called bend.ipt. It can be found in your Chapter 10 exercise folder. Before we place in some bends, let's rotate the model around. You'll see I have a whole bunch of different disjointed faces here. So what we're going to do is we're going to start off by placing a bend between this top face here and the bottom face. So from the sheet metal features, go down and select on bend. And it's asking me to select two edges. And it doesn't matter which order I select them. You'll see that I'm going to get a preview of what that bend is going to look like. So for now, let's go ahead and click on apply. And as I rotate the screen around, you can see that it placed in the bend. And since my outside faces were parallel, there really was only one solution for that. So let's rotate the model one more time. And what I want to take a look at is going to be this top disjointed face here. You see right now it's pretty much right in the middle of the bottom face. So again, for the edges, I'm going to select the edges that I want to place in the bend. I have two different options here for bend extension. The first one is extend. So let's go ahead and click OK. And you'll see what it did is it went back and removed that material from that bend. So let's go back and edit that feature. So I'm just going to double click on it. And let's change the bend extension to extend bend align to side faces. OK. And you see what it did in this case. It went back and actually trimmed back that bottom face so it's matching up with the existing edge here. Let's take a look at one more example. On the right hand side, again you see that we have our disjointed body up on top here. Meaning that in this case, these two planes are parallel. Let's see what happens when I go back and select on the bend. I'm going to select on these two edges that are parallel to each other. I have an option here, as you see, it's going back and it's placing in a bend at 90 degrees. So let's go ahead and click on OK. If I again spin that around, you can see that it placed in that bend in at 90 degrees. Let's go back and edit that bend. And as you can see, I can place this in as a full radius. Click OK. As you can see, we get a very different result by just having the single option selected, in this case, full round. What I'm going to do in this case is I'm going to go ahead and delete that bend. And let's place in another bend. And what I want to do is I'm going to select an edge on the left-hand side. Now, it doesn't matter if I select the top or the bottom edge. The result is going to be exactly the same. And now I'm going to go back and select the same edge that we did before. As I spin the model around, you can see that we have a couple different ways now of handling this. I can go back and change it to either a fixed edge or at 45 degrees. So let's go ahead and do 45 degrees. Click OK. You see the result that we get. It's placing that angle in at 45 degrees, just as the command stated. Let's go back and edit that. With the 45 degree option, I do have an option down here called flip fixed edges. In this instance here, if I go back and edit that, you see that it's maintaining that 45 degrees. Inventor allow me to go back and do a base to space. Of course, that's not going to work out well, so I'm going to take that back. The last option here is I'm going to go ahead and click on fixed edges. In this case, you see what I'm going to do is I'm going to get the Z effect. And I click OK. So let me rotate the model around so you can see our different bends that we're creating with different edges. So depending upon the faces that you're working with, if they are parallel to each other or perpendicular with each other, you have many different choices and options for creating different bends. In this lesson, we're going to cover the cut tool that is found in the sheet metal environment. The file that we're going to use for this lesson is called smstyles.ipt. It can be found in your Chapter 10 exercise folder. For the first portion of this lesson, what I'd like to do is create a rectangular cut that's going to start 10 millimeters from this front edge, and it's going to wrap all the way around. And what I'd like it to do is stop at 25 millimeters before it hits this back edge. So what I can't do is I can't just make a rectangular cut and cut it all the way through, being that I don't want it to be 10 millimeters on both sides. So the way that we're going to do this is I'm going to make this front face the active sketch, and I'm just going to stick in an isometric view. I'm just going to draw in a rectangle. And really the only dimension that I'm concerned about in this lesson is going to be the length dimension off that edge. Of course, you can go back and dimension off this other edge as required. What I want to do now, if I go back and do an update, if I would go back and do a cut here, of course the problem would be is that it's not going to wrap itself all the way around. Or if I did an extrusion all the way through, of course it's going to be 10 millimeters. So what I want to do next from the 2D sketch panel, I'm going to slide on down here, and I'm looking for the tool called Project Flat Pattern. Yours may be at the top level called Project Geometry. So from that drop-down list, select Project Flat Pattern. And what that's going to allow me to do is actually select faces that develop up the flat pattern. So in this case, I'm going to select the very back face. And as I rotate my screen, you'll see that all of the faces that define that part are coming back off into our single piece of geometry here. So now what I can do is I'm going to dimension this as though I were going to dimension that off of the regular edge. In this case, it's the projected flat pattern. And let's make this 25 millimeters. Click return. Let's exit out of the sketch environment. Now I can go back and do my cut. The profile is going to be my rectangle. And the important part here is I want to click on cut across bend. And this is the major difference between this and the extrude tool, where I can now not only designate the distance, but I can have cut across the bend. So let's rotate the model around. You can see that our cut has definitely gone in with two different values here. Let's just go back and verify that. Select that measure. Select the two parallel edges, and you'll see that it's at 25 millimeters. So let's verify that under the tools column. Select that measure distance. Select my two parallel edges. You'll see that my distance is at 25 millimeters. For the next portion of this exercise, let's rotate the model around. When we're doing our cuts across bends, it doesn't necessarily have to be a rectangular cut or a slot. What I like to do in this case, I'm going to make this bottom face the active sketch. Let's rotate the screen around just a little bit. And all I'm going to do is I'm going to just draw on a circle right on that edge. And let's place a couple dimensions on there. Make it 60 millimeters in diameter. Let's dimension it off this back edge. Let's place that at 40. Click return. Again, from the sheet metal features, select on cut. I'm going to select the circle. So in this case, let's say I do not select cut across bend, just click OK. If I zoom back up on this, you'll see that that circle is only cutting through the material thickness. So let's go back and edit that feature. So from the browser, I'm just going to double click on cut 6. And let's check cut across bend. Now the circle goes all the way through across all the different bends. For this last example, let's make this front face the active sketch. I'm going to place in a polygon. Let's go with 6 sides. The ball, that will be fine. Place that in. Done. Let's go ahead and place it in constraint. So create constraint. Let's place it horizontal. I'm just going to hit D on the keyboard. Let's dimension this across the flat. We'll place it in at 60. Again, return. But what I'd like to do with this polygon shape to do is cut it so it's only going halfway through the material, so not all the way through. So I'll go ahead and click on cut. Select our polygon. Cut across the bend. But for the thickness, I'm just going to place in there divided by 2. Okay. And now my polygon is only going halfway through the material thickness. In this lesson, we're going to do the corner seam tool. The corner seam tool will allow us to place in seams between the two faces. The file that we're going to start off with for this exercise is called cornerseam.pt. Start off with this exercise by actually placing in a flange. Go ahead and start with the edge. And then zoom up tight. I'm also going to select the different height data, change it to the bend intersection. So it's just at the exact same top face. Wide. As I rotate this around, there are two issues that I've seen some progress with. May not necessarily like the corner this is coming together, so I'm going to now I have a large gap where the angle was from the first contour flange that I created. So first of all, we're going to go back, let's seal this back up. And we're going to do that by placing in a corner seam. So from the sheet metal features, select corner seam. I'm going to select my 2 edges. And now I have a couple different options for the seam. It can be a symmetric gap, the no overlap, or the reverse. And when you start to select these, you see that the colors will change. When it's red, the red is removing material, in green is add. So I'm going to go back to the symmetric gap. We can also change the gap thickness. So in this case, I'm going to divide it by 2. So it's thickness divided by 2. Let's go ahead and apply that. So that really does a much better job of cleaning up that line. It's nice and tight. Options here. So what I want to do is I'm going to change this to clear so if it's and now let's rotate it to the back so we can see that gets me a nice tighter set. Maybe we can go back and pull that later. Now let's take a look at our first edge that we looked at before. You can see that I have a big gap right down at this corner here. So again, what I'm going to do is I'm going to go back and apply a corner seam. I'm going to select my 2 edges. I'll keep the gap again at thickness divided by 2. But let's change the corner right to tear so we'll be consistent with our other side. So again, I have a very nice tight gap there. For the next portion of the exercise, I'm just going to rotate the model around. What I like to do is I can place it into flanges. I'm going to start off with the flange tool. I'm going to select the outside edges because I want it to go to the opposite side. And for the corner option, you see that we do have an auto mitering on. That's going to work really well for an inside corner. Go back and place it in the miter corner. In this case, it's an external corner, so it's not going to apply that automatically. So let's go ahead and create those flanges here. Now what I like to do is actually seal that back up so that they're going to be almost touching. Maybe we're going to do that with the corner seam tool. Select my 2 edges to place the corner seam between. And we have the exact same options that we did before. So in this case, I'm just going to go ahead and just created this corner seam. For the next portion of the exercise, I'm going to go ahead and open up a file called shell.ipt. And it can be found in your Chapter 10 exercise folder. So for this example, what I'm going to do is I'm going to shell out this part. Just a rectangle that's been extruded. You'll see that the thickness is set at 1 millimeter. I'm going to accept that default. Now what I like to do is turn this into a sheet metal part. So obviously right now this is not a sheet metal part. It's consisting of all straight edges. So first of all, let's go ahead and convert it. So under the Convert pull-down menu, let's click on Sheet Metal. And the dialog box that pops up is basically stating the fact that our thickness that we have set here should also be the exact thickness that we have set in our sheet metal style. So we'll go ahead and do that right away. Now from the sheet metal styles, the thickness is at 0.5. Let's change that to 1 to equal our thickness that we had for the shell thickness. So go ahead and save that and done. Another way to make sure that this is going to be done correctly, go back and double click on the shell, and for the thickness value, what might be a really good idea is go back and list down the parameter, and then go back and make sure that it is set to the value of thickness. So if the sheet metal style does change, the thickness here will change as well. Now for the next portion, what we need to do is we need to open up a couple of these edges so that we can go back and apply some bends and edges into the sheet metal part. How can I do that? Is again through the corner seam tool. We have the corner option. What I'm going to do is I'm going to select a couple edges. And the edges that I'm going to select basically are going to help define this base that's going to get opened up. And I'm just going to go with the gap thickness as the default. Apply that. Do the exact same thing to my 2 front edges, opening up that face as well. And we'll cancel out of that. So now if I spin this around, you'll see that our part is opened up, but it's still not a sheet metal part. So what I need to do now is apply a couple bends to the inside edges. So I'm just going to apply 4 bends. You see that Inventor allows me to select right through the part, which makes it very easy to do. and corner rounds. Corner chamfers are just like the standard chamfer tool that you're used to placing in with the standard parts, and so is the corner round, just like the fillet tool, except both of these tools are only going to be utilized on sheet metal parts and to place those features on selected corners. We're going to start off by placing in a couple corner chamfers, and the file that we're going to be utilizing here is called full.ipt. It can be found in your Chapter 10 exercise folder. So let's start off by placing in some corner chamfers. From the sheet metal features panel, I'm going to slide down, and I'm going to select corner chamfer. And just like the regular chamfer tool, we have three methods of placing our chamfers here: distance, distance and angle, and two distances. So for our example here, we're just going to do distance. The distance here is set at 6 millimeters. We'll keep that as a default. And for the corners, let's go ahead and rotate our around. Let's zoom a little bit. And as you see, as I move my cursor over these edges here, they're not really highlighted until I come across the selected corner. So in this case, everything else is being filtered out. So I can go back and I can select these specific corners that I want. The inside corner. And let's go ahead and click OK. And in the browser, you'll see that I now have an entry called corner chamfer. If I double click on that, I can go back and modify that as well. So this means I can change that to 8. And all of my chamfers now are at 8 millimeters. I'm going to go ahead and delete out that chamfer. And now next, let's go back and place in a corner round. And now from the corner round dialog box, you'll see that I can go back and designate a specific radius, and I can go back and select corners just like I was able to do with the corner chamfer. I can go back and select these corners in the graphics window, but you'll also notice under the select mode I have an option here for feature. So if I select the feature option now in the graphics window, I can go back and select specific features. So in this case, if I select the flange, and let's select our base feature. You'll see that I'm getting the highlight for that base as well. Go ahead and click OK. And our fillets have been placed on all the selected edges and the features. In this lesson, we're going to learn how to create and use the punch tool in a sheet metal environment. The file that we're going to use for this lesson is called punchstart.ipt. It can be found in your Chapter 10 exercise folder. Inside of this file, I've already created some sketch geometry. Let's go ahead and use the Inventor tool. So you can see what it's consisting of here. I've also used some parameters to help define some of the basic shape that I want to have the user go back and define when placing in the punch. The key when creating a punch is that we need a center point, and that's what I have right in the middle of my component here. So that center point is going to be used to help locate the punch in our sheet metal part. So you'll see a lot of similarities here when creating this punch tool, is that it's the exact same workflow as though we're going to create an eye feature. Again, the only difference here is that we're going to go back and we're going to utilize a center point. That is a requirement. So what I'm going to do now from the sheet metal features, I'm going to go ahead and make this into a cut, and let's just select in our 4 areas that we want to remove that material. Let's switch to an isometric view. See what's happening. And you'll notice again I'm going to use the thickness value for the extents. So now that I have my feature created, what I want to do is extract that. I'm simply going to select from the tools pull down, extract eye feature. And the only difference here now is I need to go back and select the sheet metal punch eye feature option. And then in the graphics window, I'm just going to go ahead and select on the feature. You can see all of my parameters that I mentioned before are already populated information here. So of course I could go back and remove one if I didn't want to have the user enter and select information. Just like with an eye feature, you can go back and you can set a limit and change the props as well. So if you go back and review the lesson on creating an eye feature, we have a few more options when creating a punch. You'll notice down on the bottom here where it says manufacturing, I can go back and specify the punch ID. So in this case, when we go back and create that manufacturing side, we'll know exactly what ID punch to use. I can also go back and specify a custom depth. So custom depth is used when placing in a punch that we may have some deformation of the material, and you may want to punch it a little bit further. This information here for the manufacturing of the ID and the custom can go back and get pulled out when placing in a whole table that will pull the information from the punch. We also have the option here for a simplified representation. And in this file, I've already created a second sketch that we can go back for a simplified representation. So I'm going to go ahead and click on Sketch, and click on Sketch 3 in the browser. Now if I move the dialog box over, you'll see that my simplified sketch, in this case, really is kind of defined of my three profiles here, and they all come into a single intersection, so it's a little bit easier to see on the manufacturing side. And when we go back and actually create a flat pattern, that's when we can go back and designate which of these representations we want to see. Do we want to see punched, or just the simplified representation, or the center mark? And there's a fourth option, the representation and the center mark. So we'll cover that in the lesson on flat patterns. So next, let's go ahead and save our file. And I'm going to call it CBT punch. And I'm going to place this into my punches folder. Click save. I'm being warned that it's not in the project. In this case, that's okay. So now let's start up a new sheet metal part that we want to place this into. So we'll just start off by drawing a rectangle. Let's give it a couple dimensions. Switch to an isometric view. I'm going to make this my first face. Now let's make it look a little bit more like a sheet metal part. I'm just going to go back and add a couple flanges. Now what I want to do is I want to place in a couple of those punches. So next, let's use the sketch tool to make the active sketch that I want to place in my punch. Now what I'm going to do is I'm going to place in a couple center points. These center points will match up to the center point that we used to create the punch tool. And of course, at this point, you can go back and place in your dimensions onto those center points. In this case, I'm just going to right click and say done. I'm going to exit out of the sketch environment. Now back to the sheet metal features panel. You can go back and select the punch tool. And from the list, let's go ahead and click on punch. Open. Now from my list here, it's defaulted to the punch. It's alerting me to the fact that I have a simplified rep. Now under the geometry tab, I can go back and rotate this if needed. So if I go back and do 45, you'll see that the geometry is rotated 45 degrees. Change that back to 0. Under the size tab, so this is where we can now go back and change the values. So I'm going to change the cut angle to 40 degrees, and the OD right now is at 10 millimeters. I'm going to make it a little bit larger. Let's make it 20. And I'm going to go ahead and click on Finish. And you'll see that the punch has been placed. Of course, in this case, I'm falling right back off. That's not a big deal. Remember, when I placed in those center points, I didn't dimension them. So just like the regular standard feature, I can go back and edit a sketch. Move that geometry over, place in a couple dimensions if needed. And of course, the punch will get updated. If I want to go back and change that, I can just double click on the feature. So in this case, let's go back and change the degrees to 50. And let's change the size to 50. Let's say diameter. And everything gets updated. So again, the manufacturing ID that we placed and the custom depth, that information can get extracted when we create a drawing view and using the full table tool. And that will be covered in the lesson on documenting sheet metal parts. So very quickly here, if I went back here now and I opened up the IDE, the punch that we just created, you'll notice that it's just like an eye feature where I can go back and I can use the feature author table tool to go back and make modifications if needed. In this lesson, we're going to cover how to create and edit a flat pattern from a folded model, and we'll also take a look at how to go back and create a flat pattern from a rolled part. We're going to start off by working with a file called flatpattern.ipt. It can be found in your Chapter 10 exercise folder. First of all, in this model, as you can see, it already has a bunch of flanges on there. And I'm going to go back and I'm going to select the base that I want to have be the base, meaning that all of my other flanges in this case are going to go back and bend around that itself. So now that I have that base selected, I go ahead and click on the flat pattern. And as you can see, my flat pattern has been generated here. Also in the browser, you'll notice I now have an entry here called flat pattern. So these are two separate environments. So I can go back to the model, folded, by just double clicking on that. Or to go back to the flat pattern itself, just double click on that. So it's very easy to go back and switch between those environments. Now that I have my flat pattern generated here, I can go back and do some modifications for that. So for example, if I wanted to rotate that, go ahead and do that by right-clicking on the flat pattern in the browser and select Edit Flat Pattern Definition menu. Now at this point what we can do, you see we have a couple different alignment options. So if I want to put the alignment horizontal, I'm just going to go back and select on this angled line, and let's go ahead and apply that. And you see that that angle line is now horizontal. So let's try that again. I'm going to go back in this case, select the vertical, and let's go ahead and select our edge. And you'll notice that I have a flip option here that I'm probably going to want to use. By taking that and selecting flip, it's going to reorient the X. Click on apply. And we'll flip that back on around. So I also have an option here called the base face. If I go ahead and select on that, and then select on the apply button, the flat is going to rotate at 30 to 80 degrees, as shown here. Also in this model, I have two punches that have been previously placed, and from the punch representation tab, this is where I can go back and determine how do I want those to look in my flat pattern. So you notice I have two options up at the top here. They look very similar: default form and form punch feature. And the reason it says default, that is set at the sheet metal styles. So let's just see what they look like. In this case, of course, I am looking at it form. If I change it to the 2D representation, apply that. Back up on that. See, this is just my 2D sketch that I had represented for that. And then the next option is 2D sketch with the center mark. And lastly, we go back and select on center mark fully. And cancel, that's why we're only seeing the center mark. So let's cancel out of here for a second. And let's go back and take a look at the sheet metal styles. Now from the sheet metal styles, in this case, if I went back and said I want to show the 2D sketch rep with the center mark, save that, done. And again, I'm going to go back and edit my definition. Under the punch representation, you'll now see that the default is the 2D sketch rep with the center mark. Well, working with the sheet metal flat pattern, you may want to find out what are the extents of my flat. You can simply get that by right-clicking on the flat pattern in the browser and select extents from the menu. And a dialog box will pop up here showing you what is the width and the length of the extents of the flat. While working with the flat pattern, you may want to go back and place in some other cuts that you don't necessarily want represented in the folded model, just in the flat. We can easily do that. I'm going to make the front plane the active sketch here, and a dialog box pops up and it's going to tell me that anything that I do for this flat pattern will not be propagated to the folded part. So I'm going to go ahead and click OK. And in this case, I'm just going to draw in a circle off of that intersection, dimension it, so we'll make some dramatic change. And then going to click return, use the cut tool to remove that material. As you can see, a pretty dramatic change that we have made here. Now if I go back to the folded model, by double clicking on it, you'll see that change did not propagate forward here. However, if I go back and make a change here, so let's say I want to add a couple flanges, so I'm just going to select a couple of these edges over here, spin the part, so you can see that we definitely went and created some new additions to the model here. So now if I go back to the flat, just by double-clicking on it in the browser, you'll see that we have our new entry there. So let's go back and just take a look at it, so we're going to plan at it. So the model associativity change that we do there is going to be directly reflected back into the flat pattern. When working with flat patterns, it's very common that we need to go back and export this to another file format, for example, DWG or DXF file. You can simply do that by right-clicking on the flat pattern in the browser, then select Save Copy As from the menu. Now from the menu, we have a couple different choices for the file type, so an SAT, DWG, or DXF. In this case, I'm going to select DWG, and I'm going to select on Save. Now in the Flat Pattern DWG Export Options dialog box, this is where we can go back and determine exactly what we're going to save out. So on the right-hand side here, which AutoCAD version do we need to go back down to? Under the Layers tab, this is where we can specify which object will be placed on each layer name, and do we want that layer's visibility on or off? Under the Geometry tab, this is where you can go back and control exactly what's going to be exported. So for example, by default, we have replaced the splines. There's a lot of manufacturing machines that cannot cut a spline. So in this case, what we're going to do is we're going to go back and replace them with a line segment. And as you can see here, you can go back and determine the tolerance for how many line segments are going to be replaced. You can also go back and merge the profiles into polylines. And the last option here is we can move the entire flat pattern into the first quadrant, which in this case then would take everything to the positive quadrant. After everything has been set, you may want to go back and save a configuration, and then if you go back and save that, you can always come back to that configuration and just drop down list and you won't have to walk through it again. So just go ahead and click OK, and our DWG file has been created. So if I go ahead and click on Open, and then select on the Flat Pattern DWG. Remember, I'm doing this right inside the Inventor. I now have my flat pattern right inside the DWG file. So next what I'm going to do is I'm going to go ahead and close out this file, and I'm going to switch to a window here called Roll. So this file is well as found in your Chapter 10 exercise folder. And the example here is just a simple cylinder. As you see here, I have a slit in here, so it's not going 360 degrees, otherwise we're just going to be able to unfold that. Now a very common problem that people experience here is they'll select the flat pattern immediately here, and of course it doesn't look like it created it as a flat, and we're also getting a warning basically stating that Inventor does not know how to handle this. So I'm going to cancel out of that. I'm going to switch to an isometric view again, and the key here to unfold a rolled part is select the inside face, and now I'm going to select the flat pattern. Now Inventor is going to know what to do with that. So when I selected the flat tool, Inventor didn't have a flat face for it to work with here, so that's why I got the error in the first place here. But by selecting the inside face, Inventor knew exactly what to do with that and unfolded it correctly for me. In this lesson, we're going to introduce how to use Inventor's common tools such as holes, work planes, and how to mirror features while creating a sheet metal part. The file that we're going to use for this example is called smstyle.ipt, and it can be found in your Chapter 10 exercise folder. I'm going to start off by going into the sheet metal features panel, and from down here I'm going to go ahead and select on the flange tool, and I'm just going to place in a simple flange going up, and let's make it a little bit larger so you can see it, 50 millimeters. And what I want to do is I want to place in a hole. So from the sheet metal features panel, if I slide on down here, you'll start to see Inventor's common tools. So for example, we have the hole tool, and the work planes and work axes. So let's start off by placing in a work plane. And I'm just going to select my two inside planes so I can get a plane right in the middle. And what I like to do at this point is go back and I want to mirror the flange over. So again, I'm just going to slide on down, and again here we can see some other tools that you're definitely familiar with, the rectangle, circular patterns. So now in this case, let's go ahead and select on mirror. I'm going to select the flange that I want to mirror over. And for the mirror plane, let's select our work plane. So go ahead and select OK. So as you see, there's no difference working in the sheet metal environment as though you were working on just a regular part file. So let's slide back up here a little bit. And I'm going to go back and I want to place in a hole. So let's zoom up here a little bit. I'm just going to place in a linear hole. And let's come back off 2 edges. So let's get 25 millimeters off this edge and 20 millimeters off the top. You'll notice that the distance for the extents is defaulting to the thickness, which is our sheet metal parameter. Let's go back and make the diameter 15 so we can see it. And let's go ahead and click on OK. So you see now that I placed in that hole, it didn't automatically get mirrored over. So just like a regular standard part, you'll notice that the hole in the browser is appearing after the mirror. So I'm just going to reorder that so it appears above the mirror. And then let's go back and edit that mirror just by double clicking on it. And I'll click on the feature option and select on the hole. And then OK, and our hole gets repopulated back. So just like you would expect with the mirror tool, if I come back and I edit the flange that we first placed in, and let's change it from 50 to 100, you'll see that both sides get updated. So when creating sheet metal parts, feel free to use Inventor's common tools where applicable. The only tool that we really want to stay away from is going to be the extrude tool when we're trying to create faces and flanges. In this case, go back and use Inventor's tools, for example, face and flange to do those. That way you'll be making sure that you maintain Inventor's link to those sheet metal parameters. In this lesson, we're going to cover how to document sheet metal parts. I just created a brand new drawing file. I'm going to start off documenting the sheet metal part like you would any other part or assembly file. I'm going to start off by selecting the base view tool. And I'm going to go back and I'm going to navigate out. And I'm going to select the file called document.ipt, called in our chapter 10 exercise folder. Go ahead and click on open. And you see in our drawing view dialog box we have 2 options when dealing with sheet metal parts. I can document this in the folded or the flat. So let's go ahead and do the folded model. So let's go ahead and just kind of place it right in front of you. And just like any other file view that I can pull off projected views, so we'll pull a couple of those off. And of course we can go back and we can annotate those as with any other part. I'm going to go back and I'm going to create another base view. And I'm going to place the flat pattern now up here. You could also go back and create another sheet and place the flat pattern on that other sheet. I'm just going to place it all in the same one. So again, I'm just going to go back to the base view tool, navigate back out, select our same component, click open, and in this case I'm going to select the flat pattern option, and I do want to recover the punch center because the file that we have does have a couple punches on there. And I'm going to go ahead and place in that view on the right hand corner, and let's zoom up on that a little bit. So as you can see, Inventor went and placed in the bend lines for me. So what I want to do next is let's go back and annotate out our flat pattern. So I'm going to switch the panel to the annotation panel. And here we can go back and you can use your dimensioning tools as needed. So I'll just go ahead and place in a couple. So there's really no difference here. So right click, done. So next let's take a look at some tools that are built specifically for sheet metal. Under the hole and thread notes, under our drop down list, you'll see that we have a tool here called bend notes. I'm going to go ahead and select on that. And what I can do is I can go back and individually select on the individual bend lines if I want. Or go back and do a window or a crossing. That's what I'm going to do on the right hand side here. You can see all my bend information is coming back in. I'm going to right click, done. Now what I can do is I can move my cursor over one of these bend notes and pull the green circle. I can pull the annotation so it's out of the drawing view itself here. So you just keep working your way around on that. Now, what I'd like to do is get some more information in regards to those bends in a table. So from the annotation panel, we're going to slide on down. Now I'm going to go ahead and select on the table tool. And in the table dialog box, I'm going to select our flat pattern view. So I'm going to take all of the defaults here. I'm just going to go ahead and click on OK. And I now have a table that's telling manufacturing specifically what to do with each of those bends. They're going to be bent up and down, specifically what angle. So next what I'd like to do is pull some information in regards to the punches and the holes. So what I'm going to do, I'm going to go back and create a hole table, and you can use any of the options that you want. In this case I am going to use the hole option. I'm going to select the one in the view, place in my origin down in the left hand corner. Let's place in our hole table. And you see at this point it's only showing me information about the two holes that I have here. So what I want to do is I want to go back and edit that table to also pull information about the punches. So I'm going to double click on the table. And now from the Edit Hole Table dialog box, I want to tell Inventor to go back and also grab information about the center marks and also the punch centers. So let's go ahead and apply that. And if I move this out of the way here, you'll see I now have my information in regards to the punches. See, they're labeled B1 and C1, but it's really not telling me any information. When we placed in that punch, I also gave it a punch ID. So what I'm going to do is I'm going to go back to the Edit Hole dialog, and from the Formatting tab, I'm going to go ahead and select on Column Chooser. This is where we can go back and add some information. So in this case, I now want to select the punch ID. And I also went back and I specified a punch depth. I created that punch, so I'm going to add that one as well. Go ahead and click OK. Okay. And I now have a table built that's also specifying the punch information. Of course, I don't have a description for that, so I could double click on the dash. And here I can go back and just type in some information. In this case, I'll just generically call it punch. So let's go ahead and also add a description for the second punch. Now any change that we would make to the sheet metal part will of course replicate itself back into the flat pattern. And then of course the drawing views will get updated to reflect the changes in both the folded and the flat pattern.